Hey guys, in this video we're going to be talking about climate factors or the different factors that affect our climate or the climate of the world. So, what's the difference between weather and climate? Weather is the short term state of the atmosphere, meaning things that are very short term, like rain or hail, snow, sunny weather, etc. It changes really fast within minutes or even hours. But climates are more long term pattern of the weather, such as tropical climates or polar climates or subtropical climates. Such as in the equator, it's more tropical, it's always pretty much warm, but near the North and South Pole, it's almost always pretty much cold. There's the long-term patterns, right? And they can last years, maybe even forever. So this is already given, I believe, in your note packet. Planetary wind belts affect the climate, right? And the climate is the long-term state of the atmosphere. And we're talking about the factors that affect climate right now. So, what are the climate factors? We have latitude. Latitude affects climate. Elevation affects climate. Land and water relationship affects climate. Mountain barriers affect climate. Ocean currents affect climate. And finally, planetary wind belts affect climate. And we're going to be looking at all of these individually. So, let's start with the relationship between latitude and climate. So, to understand latitude and the relationship, we need to understand what insolation is. Insolation is the incoming solar radiation, meaning the sun's energy that's coming to the earth, and how much sunlight a particular area of the earth receives. Okay, so basically, the amount of sunlight that a particular part of the earth is receiving is called insolation. Notice the word sol, right? Sol means sun. So another vocabulary term you should know is the angle of insolation, the angle that the sun's light is striking the earth. So yes, the insolation is the amount of sunlight coming in, but the angle at which the sun is coming in is really important, and it determines the climate of different regions. Okay, and this is the angle at which, an example of an angle at which the sunlight is coming in. So, one thing you need to know, remember, lower latitudes are near the equator, 0 degrees, and higher latitudes are closer to the poles because our numbers for latitudes are increasing, right? So that's why lower latitudes are actually by the equator warmer, and higher latitudes near the poles are cooler. But why? The reason is because of how the sun's light or sun's angle of insolation hits the earth in different areas. For instance, if you notice by the equator, the sun's light hits in very directly, almost like 90 degrees, right? So if you were a person standing here, you would probably feel the sun right above your head. But notice near the North and South Pole, the sun is coming at an angle. It's not as direct. It's almost like turning on a flashlight, but like shining it at an angle and not directly at something. Okay? And because it comes in at an angle like this and even like this, right? Notice that the light is more spread out, and that is because the light is more spread out, there's less energy, there's less intensity of that light, that sunlight in the North and South Pole. And since the sunlight is more spread out, it's less energetic because of the way the angle at which the sun is coming in. It's more cooler in those areas. The sun just that sunlight and that angle just doesn't have a lot of energy. And this is another example. In polar regions, the angle is much lower, right? It's not a 90-degree angle like you see by the equator where like the sun is directly above your head, like sharp. Um, it's more at a lower angle coming from the sides almost. If you were to flash us a flashlight from the side, it would be spread out and be less intense. But notice by the equator, it's warmer because the sun strikes most directly there. It's almost a 90-degree angle. These arrows are showing sunlight or the angle of insolation, right? By the equator, the sun is hitting at a 90-degree angle. This is your angle. Um, uh, in relation to the surface of the earth, and that's why it's so intense there, and that's why it's so warm. In the mid latitudes, like around 30 to 60-degree north, our sunlight is not coming in directly at 90 degrees, but it's coming in at around a 45-degree angle. And that's less intense at the equator, but more intense at the polar regions. Notice that the polar regions, the angle of sunlight is much lower. So, in other words, the higher your latitude by the poles, the lower the angle of insolation. Your sunlight is coming at a really low angle, and that's why it's less intense and it's cooler in those areas. But in lower latitudes near the equator, we have a higher angle of insolation. The sun is coming in at a large angle, 90-degree angle pretty much, and that's why it's warmer. So go ahead and write this down in your notebook or note packet. One of the factors for climate is latitude. Latitude affects climate because the higher your latitude is near the North and South Pole, the lower your angle of insolation, and that's why it's less intense and more spread out the sunlight, and that's why it's cooler in those regions. So pause this video, try number 9. Base your answers to the questions on the map below and on your knowledge of Earth science. The map shows the continental United States and parts of Mexico and Canada. Letters A through F represent surface locations. The table below compares the average annual temperatures for location C and location F. Notice that location C's average annual temperature is 55 degrees Fahrenheit, and location F's average annual temperature is 68 degrees Fahrenheit. Location F is warmer. Now, the best explanation for this temperature difference is at location C is, try this. The correct answer is B is farther, location C is farther from the equator. And that makes sense, right? Remember, Mexico is closer to the equator than Canada or even the US. So, F is much closer to the equator than location C is. Location C is at a higher latitude. And since it's at a higher latitude, the sun is coming at a lower angle. It's not as intense. And that's why it's colder in C and warmer in F. So, the higher your latitude, the colder it is. The lower your latitude, the warmer it is. Try number 10, pause this video. The map below shows an eastern portion of North America. Points A and B represent locations on the eastern shoreline. Which factor is primarily responsible for location A having a lower average yearly temperature than location B? The correct answer is, once again, latitude. And we know it's latitude because notice that there's not much difference between location A and B. They're both by the water. They're both towards the eastern side of the North America. So that's why I'm narrowing it down to latitude. Although there are other factors to consider that we will talk about. And once again, A is farther from the equator, so it's lower angle of insolation and it's cooler. And B is closer to the equator, such as Mexico and Florida. Those areas are both closer to the equator, and that's why it has a lower, higher angle of insolation and warmer. Try 11, pause this video. Which graph best represents the general relationship between latitude and average surface temperatures? The correct answer is B. As your latitude increases from 0 to 90 degrees towards the North Pole, my average surface temperatures in our locations are actually decreasing. They're getting cooler as we're going towards the 90-degree north. In the next video, we're going to talk about the relationship between elevation and climate.